A familiar login page loads on the correct identity provider domain. The password and MFA flow are genuine. Then an unfamiliar application asks to read files, mail, or contacts. The page can be real while the request behind it is malicious. That is the central trick in OAuth consent phishing. In this CipherVibe lesson, we will trace one fictional consent request, identify the warning signals, show what defenders can log, revoke the synthetic grant, and rerun it through a safer approval policy. The lab creates no application, authorization code, access token, or external request. OAuth lets a user authorize an application to access specific resources without giving that application the user's password. Authentication answers who the user is. Consent authorizes what the application may access on the user's behalf. Attackers exploit confusion between those two separate decisions. People recognize the identity provider, complete MFA, and assume the remaining screen belongs to the same trusted service. But the consent page is describing a separate application. The provider can accurately display a dangerous request. Users must evaluate the app, publisher, scopes, and purpose. The lure may promise a shared document, meeting recording, workflow tool, security update, or support action. Its link leads to a legitimate authorization endpoint for an attacker-controlled application. The application name and icon can imitate a familiar task, but the requested access tells the real story. Our local simulation uses Morgan, identity.demo.local, and a fictional app called Northstar Notes. The scopes are plain training labels such as read demo files and send demo messages. The grant button changes only an in-memory state field. It cannot create tokens or access data. The safe baseline is a user deliberately opening a note viewer that requests one narrow permission in context. The publisher is known, the app has an owner, the purpose is documented, and access expires. The permission supports the feature the user just requested. The suspicious version asks for far more than a note viewer needs: broad file access, the ability to send messages, and continuing access when the user is away. A real provider may list those permissions perfectly. The mismatch between stated purpose and requested capability is the red flag. Before allowing access, ask 5 questions. Do I recognize the exact application? Is the publisher expected and verified? Do the permissions match the feature? Did I initiate this action? How long will access persist? If any answer is unclear, cancel and verify through a known channel. To model the defensive consequence, the simulator records a grant event for Morgan, Northstar Notes, and 3 training scopes. No secret is issued. The audit record includes user, application identifier, publisher state, requested permissions, consent type, time, source channel, and correlation identifier. Defenders should alert on new or rare applications, unverified publishers, high-impact delegated permissions, consent from privileged users, bursts of grants, and activity inconsistent with the app's purpose. Correlate the grant with subsequent file, mail, directory, or API access and the original message that drove the user. When an illicit grant is confirmed, disable the application according to platform guidance, revoke the consent grant and related tokens, block further consent, and review what the application accessed or changed. Protect affected users and investigate the lore. Resetting a password alone does not necessarily remove an external application's authorization. Organizations can restrict user consent to verified publishers and permissions classified as low impact, while routing higher-risk requests through an administrator approval workflow. That workflow should validate business owner, publisher, redirect configuration, requested scopes, data classification, necessity, and expiration. Legitimate developers should request the narrowest practical scope, ask only when the user invokes the related feature, explain why it is needed, and handle denial safely. Bundling broad permissions at first sign-in trains users to approve without understanding and makes malicious requests harder to distinguish. Maintain an inventory of third-party applications, publishers, owners, users, permissions, risk ratings, and last activity. Review sensitive grants on a schedule. Expire unused or time-bound integrations automatically. An application without an accountable owner, current purpose, and support path should not retain access indefinitely. We rerun the fictional consent event with policy enabled. Northstar Notes requests permissions beyond its registered purpose. User consent is denied, no grant record becomes active, and a review ticket captures the app, publisher, scopes, requester, and source message. The final event shows a controlled refusal rather than a token. Do not stop with one user. Determine whether the app exists elsewhere, whether administrator consent expanded its reach, whether credentials or redirect settings changed, and which users received the lore. Preserve audit evidence, search for related applications and publishers, and verify that revocation propagated everywhere. Test applications that request missing, conflicting, or excessive scopes. Verify that blocked grants produce useful audit events, revocation ends access promptly, approval workflows identify an accountable owner, and expired apps cannot silently return. Measure new grants, high-risk scopes, review time, and orphaned integrations. Remember the rule: a real login page proves the identity provider, not the requesting application. Cancel unclear consent prompts. For defenders, restrict high-risk consent, inventory existing grants, and rehearse revocation. The complete detection and response checklist is available on CipherVibe.